Hello Gators, this is 8-1, right triangles in the Pythagorean theorem. I know you've seen the Pythagorean theorem, let's prove it right now. And the way we're going to do it is we're going to use similar triangles in this right triangle with an altitude drawn to the hypotenuse. We're going to use the theorem we used in the last chapter, and we're going to use this leg B. So the leg B is the geometric mean between the hypotenuse, which is C, and the side that's adjacent to the leg, which is B, which is F. And if you cross multiply, you're going to get CF equal to B squared. We're going to do it with the other leg as well. So we're going to use this leg, A. It's going to be the geometric mean between the hypotenuse and the side that's adjacent to the leg, which is E. I'm going to cross multiply and I'm going to get CE equals A squared. Okay, so our first step is given. We have a right triangle. Our second step is we draw this perpendicular, or this altitude, to the hypotenuse. And our third step is the theorem that I just talked about. In a right triangle, we know that the leg is the geometric mean between the hypotenuse and the adjacent side. All right, so now we have these two right here for that. Now we're going to take this and I'm going to add the same thing to both sides. So I'm going to put CE here. I have A squared here, and I am going to add the same thing to both sides. I'm going to add B squared, and that's the addition property of equality. All right, now that I have this, I am going to take this B squared and I'm going to rewrite it. I'm going to put B squared is equal to CF, so I'll put a CF right here, and that's called substitution. And then I am going to factor out a C, so that's factor. And I want to notice what E plus F is equal to. E is a small is equal to the big, which is C, and that's the segment addition postulate. Little plus little equals big. I'm going to take this part right here and I'm going to substitute it. I'm going to take it out and put C in its place, substitution. And now I know that C times C is C squared. So this is the Pythagorean theorem. All right, and so the Pythagorean theorem says if you have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. Let's go ahead and practice finding a hypotenuse here. This is a hypotenuse that's opposite the leg. This leg right here is a little a because it's opposite angle A. So this will be a 15 squared. And this is angle B, so this is side B. And side B will be equal to 12 squared. And we're trying to find the hypotenuse, which is C squared. Okay, when I square those, that'll be 225 plus 144, and that equals C squared. And 225 plus 144 equals 369. And then I'm going to take the square root of both sides. And when I take the square root, I get approximately 19.2. That's going to be equal to C. All right, let's do the next problem. Now, notice that we do have a hypotenuse, but we're missing a leg. So on one of the leg, we don't know the D, so we're going to say D squared. We do know E because here's angle E, and this is going to be side E. Side E is always opposite angle E, so that's going to be 7 squared equals, and then F, here's angle F, so this will be side little f, and that'll be 10 squared. So D squared will equal 49, plus 49, equals 100. So D squared will equal 51. And if you take the square root of both sides, D is approximately, and the square root of 51 is approximately 7.1. All right, Pythagorean triples are three numbers that satisfy the Pythagorean theorem. So you can see the numbers 3, 4, and 5, when you put them in to the Pythagorean theorem, they work. And notice that 6, 8, and 10 also work. And that's not a surprise because 3, 4, 5, and 6, 8, 10 are similar triangles by SSS similarity. And here's some other triples: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And any multiple of it, because those multiples will be similar triangles. Let's go ahead and decide and find x, and while we're finding x, decide if we have a triple. Okay, so I do know that this is the hypotenuse, so it doesn't really matter which leg you put for each. And then this is going to be 16 plus 36 x squared, and x squared is equal to 52. Now, when I take the square root of both sides, I know I am not going to get an integer. I'll get a number, but not an integer. So I have found what x is. I can put it in the calculator. Square root of 52 is approximately, x is approximately 7.2, and this is not a triple. Triples are always three numbers that are integers. Okay, let's try this one. Now I notice that 5 is the hypotenuse, so I'll write x squared plus 3 squared is equal to 5 squared. X squared plus 9 is equal to 25. X squared is equal to 16. I'm going to take the square root of both sides, and x will be equal to 4. Notice that this side is a integer. So this is, yes, this is a triple. Triples are only three numbers, and they all have to be integers. Let's talk about the converse of the Pythagorean theorem. If you see three numbers that satisfy this a squared plus b squared equals c squared, then we can say it's a right triangle. Let's take a look at this problem. This problem for sure is a right triangle. So the hypothesis is that it's a right triangle. So we know for sure that the Pythagorean theorem will work. Now notice that we're looking for KL, and KL is little j right here. This is angle j, this is little j opposite it. So we know that this will be 9 squared plus 40 squared is equal to j squared. And let me go ahead and put that in the calculator. 40 squared plus 9 squared. That answer is 1,681 is equal to j squared. We're going to take the square root of that, and that answer is 41. When I take the square root of this side and square root of this side, j will be equal to 41. And when this is equal to 41, this is an integer. This is a triple. It's an unusual triple, but it is a triple. Now this is an entirely different problem. What the question is asking is this a right triangle? So we're going to use this theorem. We're going to decide if the theorem works, if the n squared plus m squared equal o squared works, then we can say it's a triangle. Okay, now I always want to make the hypotenuse the number that's by itself. And so the biggest number is 37. So I'm going to make n and m. M is, m is the biggest number, so that should have been, this should have been m, and this could have been o. We always want to make the biggest number right here. So this is 37 squared, and then the other two numbers will be over here. We always want the biggest number there. And I'm going to put a question mark because I'm not sure this is going to work. So I'll write 35 squared plus 12 squared, and I'm getting the answer 1,369, and 37, I'm going to square that, and I'm getting 1,369. So there is no question, these are equal, and so the answer is yes, this is a right triangle. Okay, let's decide whether each of these is a right triangle. Now, I notice this is square root 113. Square root 113 is greater than 10 because root 100 is 10, and this number is bigger. So I know I want to put that right in here for the biggest number. So I'm going to write square root of 113. I'm going to put it in for the c squared, and then I'm going to put this 8 squared and 7 squared here. Now this is going to be 64 plus 49, and this number is 113. And when you take the square of the square root, that is also 113. So there is no question, these are equal. So the answer is yes, this is a right triangle. All right, now let's try this one. Now this one is square root of 95. Square root of 95 is bigger than square root of 81. Square root of 81 is 9. So I know this number is bigger than 36. So I want to put this number in for C. 4 root 95. I want to put that in for C. And then I'm going to put the 36 here and the 15 here. And I'm going to try to figure out what this answer is using my calculator. And that answer is 1,521. Now this means 4 times 4 times root 95 times root 95. That's what squaring means. So that's going to be 16 times 95, and that answers 1,520. Now these are not equal, so the answer is no. It's not a right triangle. Okay, and here's the summary, the Pythagorean theorem and the converse.